All right, excellent. Thank you. So welcome to this session about DevOps with Azure Kubernetes Service here at NDC London. I hope you had a great conference so far. My name is Jakob Jan, and I'm a Microsoft Azure MVP working at Active Solution based here in snowy Stockholm, Sweden. And we work a lot with mainly applications based on Azure, and we see a growing interest in Kubernetes, specifically around Azure Kubernetes Service the last couple of years. So I want to share some experiences around kind of DevOps related topics around Kubernetes. So the topic about this session is really, so you created a Kubernetes cluster, you deployed your first applications there, perhaps. Now what? What are the things that you need to think about and solve? That is not strictly related to your application in itself, more related to the cluster, to the health, and DevOps practices, so to speak. So I want to talk to you a little bit about the infrastructure as code, how you can provision not just your application, but also the cluster itself using infrastructure as code. And related to that, automated deployments, again, not just for the applications, but also for the cluster, to make sure that we have a consistent set of cluster infrastructure that you can deploy in a safe and repeatable way. Getting feedback back from the cluster, back from the application about the health, performance, and so on is, of course, super important. So I'm going to talk a bit about how you can deal with this in Azure using Azure Monitor and how AKS integrates with that. And then we have the topics of availability and scalability. So, making sure the application actually stays alive, stays respondent, even though maybe your applications are being, getting a high load, or perhaps you get could be a problem with, one of the data centers in Azure. So you want to make sure that you can fail over, for example, to another data center, to another region, perhaps, and still be respondent and available to your end users. So just a quick word about Azure Kubernetes Service. This is the managed service in Azure for Kubernetes, where Microsoft or Azure handles all the things related to the control plane. So that is the master nodes. You don't really see them. You can't access them. You don't pay for them. You only pay for the nodes. So these are the virtual machines that will be running your applications. And AKS handles things like upgrades, patching of the nodes, auto-scaling, and those kind of things. So this is a huge benefit, of course, compared to running Kubernetes on-premise, where you have to deal with the things yourself. And Kubernetes can be run in everywhere, both on-premise and I think all of the cloud providers have their offering. So some things are, of course, specific to Azure if you run it in AKS. So first up, the virtual machines, your nodes, when you deploy a cluster in Azure, they will be part of a virtual machine scale set. So this is what allows AKS to scale your cluster up and down based on how you configure the auto-scaling. When you want to expose your application in Kubernetes, you create what's called a service, and you can configure that service to be a type of load balancer. When you do this in AKS, that will automatically configure the Azure load balancer to route the traffic from the outside of the cluster into that cluster to the correct IP and so on. So that's something that is handled automatically for you. With Kubernetes, you also very often use something that's called an ingress, which is for more powerful HTTP-based routing to route traffic based on URL paths and so on. And if you do this in AKS, you can have that also automatically configuring Azure DNS records for you. So you can access various parts of your system based on DNS records. So this can also be handled automatically for you. In terms of authentication identity, every time you create a cluster, you need to provide it with an identity. So this can either be a service principal or, better yet, a managed identity, which is a fairly recent addition to AKS. So either way, you define an identity for this cluster, and that is important when you need to access other resources, other services in Azure. A very common example is that you need to pull your Docker images from a container registry in this case, the Azure Container Registry. And when you do that, you need to make sure that the cluster has the necessary permissions to do so. So you will give that to the identity or the service principal of that cluster. AKS also supports Kubernetes role-based access control, and this then integrates with Azure Active Directory, meaning that you can, when you need to provide access to the cluster, you can do that based on users and group in Azure Active Directory, and still use the standard role-based access control in Kubernetes to do so. So you can map that to typically to groups then, so you can give, for example, cluster admins the necessary permissions to administrate the clusters and so on. When you need some kind of external storage for your containers in Kubernetes, this is called a persisted volume. And when you do this in Azure, you can map this to either an Azure file, so that's a storage account, or to an Azure disk, so a disk attached to your virtual machines. So this is configurable how you want to persist that storage. And finally, Azure Monitor, as I mentioned before, this is a service in Azure that basically all resources integrates with, and so does AKS. So everything that you run, either your applications and also the nodes, everything related to cluster will send data to Azure Monitor if you tell it to do so. And that will give you a lot of insight into the health and the state of your applications and the cluster. So let's talk a little bit about infrastructure as code then. So, this means that instead of just creating a cluster manually through the portal, for example, and switch with some settings there, you define the cluster in source code, and you have various options here how you do this. But the important thing that this is code, you check that into source control, either together with your application or maybe as in a separate infrastructure repository. And by doing this, you will get a consistent infrastructure. It's very common to actually deploy not just one cluster, but multiple clusters. It could be clusters for various environments, so that's as prod, or you can have multiple clusters where you dedicate a cluster to a particular application, for example. So either way, you want to make sure that these clusters actually are consistent. And the only real way to do this is to actually provision it used in code there. So, of course, this will now also give you repeatable deployments. You can deploy this over and over again, making sure that you have the correct state. Also making sure that you don't get configuration drift, whereby someone actually modifies some cluster on the fly somewhere. That is not a good thing to do, and you shouldn't really give them permission to do so. Everything should go through a deployment pipeline. And this also allows you to spin up clusters on demand, which is actually a quite common thing to do. A common example is if you're working with pull requests, you will create a separate branch where you develop some new functionality, and then you can have a pipeline creating a cluster for that particular pull request branch, deploying the application into the cluster, doing some automated testing perhaps, or some other kinds of testing, and then when you're done, you can just remove the cluster and delete it. So this is actually a very efficient way to work with the Kubernetes, and it actually allows you to do this pretty fast as well. And of course, it will save you some costs by not having clusters run all the time unless you actually need it. So you have multiple options here to how you want to implement this. ARM templates is, of course, the native option in Azure Resource Manager templates, and this is what I'm going to show you. But there are also other options, and I highly recommend you to look into both Terraform and Pulumi as two other options for doing infrastructure as code, not just for Azure. These are cross-cloud supported. You can also use the Azure CLI, in fact, to implement this. So multiple options. You need to kind of decide for yourself which options is the best for you. Now, when we talk about deploying the infrastructure in AKS, we're not just talking about the cluster, because you can see Kubernetes as a platform where you then will deploy your different applications from different teams. And typically that requires more than just creating a bare bone cluster. So first up, every cluster needs to run in a virtual network. So typically you will make sure that you have a virtual network set up before you create the cluster and configure it properly. Next up, you deploy the cluster itself. And And once that is done, some more things that you typically want to do as part of the infrastructure pipeline is you create namespaces. So, namespaces in Kubernetes, this is how you can divide a cluster into multiple parts. You can, for example, divide it up to, you could potentially have a dev and a test namespace in the same cluster, or you can have separate namespaces for multiple applications. If you have multiple applications running in the same cluster, you can divide it up, or you should divide them up using namespaces. So consider this as part of the infrastructure and create them at the same time that you create the cluster. Next up, you typically want to have some kind of ingress controller, and related to that, the certificate manager. So this is for handling HTTP traffic or HTTPS traffic going from the outside into your cluster. So again, this is often considered as part of the underlying infrastructure and not really part of the application that you deploy later on. So instead, you want to make sure that when you create a new cluster, you already have this set up, so the application can just deploy and then use these resources. Also, you want to set up the necessary permissions. So you create service accounts in Kubernetes. You create necessary Azure AD groups and the roles and role bindings in Kubernetes. So that is in place. So for each team, you need to set up permissions for them to actually be able to deploy their applications using some kind of deployment pipeline. And also, if they need access to the cluster, you should provision this as part of the infrastructure pipeline. So let's talk about automated deployment then. Let's say that you have two clusters. First, you have a dev test cluster where you have separated them into two different namespaces. And then you have a separate production cluster, which might be typically running more nodes, maybe more powerful nodes, and so on. Then if we're looking at a typical deployment pipeline here for your applications, you would have some kind of build first, which will then produce the necessary container images, and you will push them off into the Azure Container Registry, where you can select which registry you want to use here. And then you have a staged deployment pipeline here, where you first deploy the new version into the dev namespace, run some testing, might go into the test namespace, and so on. And finally, you will deploy into production. So this is part then of the application pipeline. But again, you should have a pipeline also for the infrastructure, which actually creates the clusters to start with, as I talked about, and doing all the steps that I just mentioned here. Now, if you have clusters dedicated to a single application, you might consider this to be the same pipeline. You can actually combine these two into the same pipeline. So at the same time, when you deploy a new application, you will also make sure that the cluster is up to date. Otherwise, it's quite common to kind of consider the cluster to be part of the infrastructure. So this is located in an infrastructure repository, and you have a separate pipeline there. It might be a separate team that actually owns that repository. And any changes going out to the cluster is done through that pipeline to make sure that they are up to date and consistent and so on. So talking about application pipelines, I'm going to use Azure Pipelines for this session to show you how you can set this up. And of course, you can use any kind of CI/CD automation tool here. But there are some things specifically for Kubernetes here in Azure Pipelines that I want to show you. So when you do set up a pipeline in Azure Pipelines, they are typically consist of a set of stages. So each stage typically corresponds to an environment. So you could have dev test prod, for example. And each stage then running multiple jobs, one or more jobs on some agent somewhere. And so if you want to have this pipeline deploy into a cluster, into a specific namespace, then in your cluster, what you do in Azure Pipelines is that you create something called an environment here. So the environment really encapsulates a namespace in Kubernetes in a specific cluster, and it contains then a service connection, which really is the necessary credentials to be able to deploy into that namespace. And this environment concept also gives you great visibility into that cluster, and I will show you how that looks in Azure Pipelines. So it lets, for example, the developers through Azure Pipelines actually take a look inside your cluster to see, for example, troubleshooting deployments and so on. That's a great addition. Also, something that it provides is functionality related to pull requests. as I mentioned before, that it's very common to, for every pull request, actually create a separate deployment to test this pull request, not just doing code review, but actually deploying the pull request branch and perhaps running automated tests and so on. So there is a specific functionality here in Azure Pipelines related to Kubernetes that we can use, that in the case, if this is a pull request deployment, it will automatically create a new environment and a new namespace, and then we can deploy into that environment. So this can then be set up automatically, which is a very powerful flow then. We just create a new pull request, and minutes later we will have a new namespace with that particular version running in the cluster, and we can access it and run tests against it. So I want to show you a little bit of demos around this to start with. So let's start with the infrastructure as code. And so for this demo, let's zoom up a little bit here. I have a sample application called the Quizbox or Qbox. It's a simple quiz application, and I have two repositories here. It's the Qbox, that's the actual application, and then I have a separate repository for the environment. So this is where I store my ARM templates and so on. So let's take a look at a few of these ARM templates, and all of this code will be available on GitHub after the session, so you can take a look there for yourself. So first up, let's just take a look at the network. This is the first part, as I mentioned before, that we need to create. And so I just want to point out a few things on this one. This is using the virtual network type here. And when you create a network, you need to make sure that it has the correct IP address prefix, so that you have enough IP addresses for your cluster and for the pods running in that cluster. I also create two different subnets, and this is a subnet. Then the first one, that's the one that we're going to deploy the cluster into. I want to make sure that that's available from the start then. So that's the network, but then the more interesting part perhaps is the cluster itself. So this is a separate ARM template. So this is actually two different ARM templates that I do. And might be easy to look in the template outline here. So let's take a look at the cluster here. So this is then using the managed cluster type. And let's just point out a few interesting things here. First up, your application will run on the nodes, and this is actually in what's called a node pool. So down here we have the profile for that node pool. So this specifies what your nodes should look like when you create them, the underlying virtual machines here. So here you specify first up, how many virtual machines do I need to start with? What size should I be using? So the number of cores and memory and so on. What type of operating system should it be? You specify the subnet ID. So this is the subnet that I just showed you before. So we're going to deploy into that subnet. And then we have a lot of more options here as well that I'll come back to later on, things like autoscaling, availability zones, and so on. Also important now that when you create a cluster, I talked about identity. So in this case, I am using a managed identity. So, and this is done with this. I'm just specifying that the identity should be system assigned. So now Azure will create a managed identity for me, and this will now be the identity of the cluster. So then I need to give that identity the necessary permissions to do a few things. So I have three different role assignments down here. The first one is I want to make sure that this cluster has the permissions to send data to Azure Monitor. So this is a specific role here, the monitoring metrics publisher. That's the first one. I also need to give it permissions into that the subnet that I just created to have it. It needs permission to create new nodes dynamically and assign it to that subnet. So it needs to have that permission as well. And finally, I need to give it the permission to pull images from the container registry. So in this case, I'm giving it the role assignment as part of the container registry namespace. And I'm giving it the role ACR pull, Azure Container Registry pull. So this is actually what then allows the cluster to pull images, the images that I'm building and publishing to that registry. And in order to run the application. So these are the ARM templates. Let's take a look at the pipeline for actually running these things. So again, I have two different pipelines, one for the environment and one for the actual application. So let's take a look at the environment pipeline first. And let's start with just looking at the latest pipeline here. So you can see here that I'm having a staged deployment here, where the first one is deploying, either creating or updating the dev test cluster. And after this, I have two more stages where I deploy one cluster in Europe and another cluster in US. So this is my production environment, which is running in two regions. But the dev test cluster is just one cluster that I can use for multiple teams. And let's take a look at the pipeline. How it looks underneath. So this is a YAML pipeline, which is what you typically use nowadays in Azure Pipelines. And here you can just you can see the stages here. I can collapse a little bit so you can see it. So this is just my stages. And if we look inside here, we can actually see that I'm using a jobs template here. And the reason for this is that I want to make sure that I'm deploying, in this case, the cluster in exactly the same way in all environments here. I don't want to have specific things going on in a specific environment. And then template, of course, is a great thing to do this. I don't have to repeat it, and I can make sure it's the same set of steps. So this is a separate file, and I'm just going to show you what this looks like. So it's a lot of details here. I'm not going to go through this in details, but here you can see that I'm doing all the things that I talked about before on the slide. So first up, I'm creating the Azure Active Directory groups. I'm creating one called Cluster Reader and another one called Cluster Admins. So I can make sure that those actually exist. And then later on, I can assign permissions for groups to be part of the, for users to be part of that group and get the necessary permissions. Next up, I'm running the ARM template for the network, the ARM template for the cluster. I'm creating namespaces, permissions, and finally I install the traffic ingress controller here. So again, this is typically various steps in the pipeline. This is the ARM template step where I deploy the network, where I deploy the cluster, and so on and so on. So the details here are not super important. It's more the fact that what we're actually doing as part of this pipeline that is interesting here. So again, this is the environment pipeline. And let's take a look at the other one, the application pipeline. It's the CD one. So this is run then every time I make a change to the application. And let's take a look at the latest run here. So down here you can see that this is also, of course, a staged pipeline where the first stage now is the build part. So you can consider build just being the first part of your pipeline, really, the first stage of your pipeline. So this is where I'm building the Docker images and pushing them to a container registry, and then I'm deploying it to the dev test cluster. And after this, it will actually wait for approval, and then when I approve it, it will go on and deploy it into my production cluster here. So again, let's take a look at this. The pipeline. We can do an edit here just to see what this looks like. And this is actually, it's simpler. Although the first stage here is the build. So this is I'm using Docker Compose here for building and pushing the images. And next up, we have again the various stages here for Europe, US, and the dev test cluster here. And again, I'm using a template here for the actual steps in the deployment. And we just take a quick look here to show you what this looks like. Switch repository here and deploy template. So this one is actually a lot simpler. I'm just using Helm here, which is a common way to package and deploy the application. So I'm just doing a Helm install to make sure I have it on the build server, and then I'm deploying the Helm charge, which is also an output from the build pipeline. So one interesting thing here now, let's go back to the run here. And if we look at the latest run now, we have this concept here of environments. So that's the one I talked about before. So here we can see that this particular run of this pipeline was deployed into these environments. And I can now view the actual environment here. And this is also available here in the pipeline hub. You have the environments. So here you can see the dev test prod EU and the prod US environments. And this is where you get the visibility actually into the cluster. So first up, you see the deployments. So I can go in here and I can see all the deployments to this particular environment into the dev test. But even more so, I can actually go kind of drill into this environment now. So this is actually a view into the cluster. So when I click on this, I actually get to see live information coming from the cluster. So this is a great feature in particular for the development teams, to make sure that the deployments are working smoothly. And if they get some kind of deployment-related error, they can go in here and look at the status of the various deployments, and you can even drill down into these pods, the actual containers running in the cluster, and make sure that the details and the YAML file that were deployed actually was correct. And they can even go and see live logs coming from the cluster like this. And of course, this information, as you will see soon, is also available through the portal and through the Kubernetes CLI tools. But it's quite common to not give all the developers access to the cluster itself. And even if you do so, you need to have some more knowledge about Kubernetes in itself. So this is actually a great way for developers to easily get access without giving them access to the cluster specifically. So, and the other feature I talked about was the fact that we can now automatically deploy pull requests and have these environments created for us. And I'm going to show you this. So I'm actually prepared a pull request here. It's a draft pull request. So I'm going to just publish it. And this will now kick off a pipeline here. So it will actually run a new run of this pipeline against this particular branch then to make sure that this branch is okay. But it will also deploy it into a new namespace. And while this is running, let's just show you how this actually is implemented. Because if we go back to our pipeline that I showed you before, let's scale up here. So we can see now that we actually had, in addition to the dev test stage here, I also have a stage that I call dev test PR. So this is a specific stage for the pull request builds. And there's a condition here to make sure that I'm only running this if the source branch is a pull request source branch. And in this case, I'm using another template here that is mostly the same as the first one that I showed you, but it has an extra step here. So in addition to doing the Helm install and Helm deploy, it has this special step called a review app. And in addition, then we have a step for creating a namespace. So this task, this is a built-in task you can just add here, and this is the one that will actually create this environment dynamically for us and set up all the permissions to be able to deploy into that namespace that we're creating here. So this is what kind of does the magic behind the scene to creating a new namespace, creating an environment in Azure Pipelines that points to that namespace, and then we can just do the normal steps here. So let's see what happens to the pipeline. If it can take a little while, some time to build it. Hopefully it should be done fairly soon. So yes, it's built in the images, now it's pushing it to the container registry. And as soon as this is done, it will start deploying it into that new namespace. So, and this, working with pull requests like this is really, really powerful. We do this all the time. So the ability to just create a new pull request, push it, and then a few minutes later have it available in an isolated namespace in the cluster, and then we can run tests against it. We can have stakeholders looking at the functionality, and they can be part of the approval process for the pull request. So it's a really powerful workflow, and this just makes the whole thing easier for actually implementing it. So let's see if we're done here. So it built, and you can see now that it skipped the dev test. It doesn't go here because this is a pull request. Instead, it triggered the deploy to the pull request stage, which is now done. So interesting thing now is if we go back to our environments here, we have the dev test .eu and .us. If I now drill down into the dev test, you will see that now we actually have an additional resource here. It's now called review app -122. 122 is actually the ID of the pull request, but the name here is something that you can configure, of course. But this resource was now created for us automatically. And if we drill down in here, we can now see the deployments that was just created into this namespace. And again, I can drill all the way down here, potentially troubleshooting any issues and so on. But again, now I have a new namespace in my cluster. I have the new version deployed into that namespace, and I still have this functionality related to environments in Azure Pipelines. So this is a really nice integration between Azure Pipelines and Kubernetes. And strongly, if you are doing Kubernetes deployment, I strongly recommend you to look into it. All right. So next up, let's talk about monitoring and feedback. So if you are working with Azure, if you're running things in Azure, you definitely have come in touch with Azure Monitor, which is the kind of the umbrella service for everything related to monitoring, to logs, to analytics, and so on. So basically, all things in running Azure will send data into Azure Monitor. So this could be both your applications, the guest operating systems, in addition, and all the various resources and services and so on, even subscriptions and tenants and so on, send different types of analytics information to these stores. So Azure Monitor basically consists of two different stores. You have the metric store and then the log store. And to the right, you can see all the options that you have. Once you have this data, what you can do with it. So first up, you have the different types of insight tooling. So for specific purposes, there is also specific type of insight that you can use. So for example, application insights is something for giving a lot of insight into your applications. So there's specific tooling for that. And then you have the container, which is the one that we're going to look at in this session. So this is Azure Monitor for containers. So again, this is specific tooling for Kubernetes to give even more insight. In addition to being able to view the metrics and the logs and so on, you have this additional functionality going on here. And then you can use, of course, you can visualize all the information here using dashboard, using Power BI and so on. And you can yourself analyze the data using both the metric analytics, which goes against the metric store, and then you have log analytics, which allows you to run queries against the log store and doing charts, doing alerts, doing working with dashboards and so on. So again, Azure Monitor for containers is a kind of a subset then of Azure Monitor. So this will now pick up, when you enable this, you will get a lot of data coming from both your containers. So anything your container logs will be sent to the log store. And in addition, Azure Monitor will then pick up metrics from your containers. So things like CPU usage, memory usage, and so on, and send this into the data stores. And in addition to your containers, also everything related to the Kubernetes cluster itself. So the nodes, the system pods running inside of there, everything, and the guest operating system, everything will also go in here and be available to you in terms of queries and dashboards and alerts and so on. So again, when you do enable this for your cluster, this is optional. You don't have to use it, but when you do, AKS will deploy the log analytics agent in a containerized version. So it will be running inside the cluster, and you connect it to the log analytics workspace. So the workspace is where all the information is stored in those data stores. You can have multiple workspaces if you want to. And then again, it collects the memory processor metrics through the Kubernetes metrics API, everything from your controllers to nodes, containers. And this is written to the metric store. And then it picks up also the logs, as I mentioned, and writes these to the log store. And enabling this is really easy, either way how you create the cluster itself. Using ARM templates, we can just specify that we want to enable this. and we give it the resource ID of the log analytics workspace where it should send the data. So let's take a look at the Azure Monitor, and specifically then for AKS. So this is a start page for Azure Monitor, and you can see here the different insights that I talked about. So you have the application insights for your application information. You have the for virtual machines, storage accounts, and so on. And then you have the containers hub here. So this is the functionality built on top of the AKS monitoring. So here I actually get a kind of a overview of all my clusters. So I have 3 clusters that I showed before. I have the test cluster, and then I have my 2 production clusters. And I can get a quick glimpse here of the status and the health of these clusters. So if anything would be faulty here, I would get another status here. And then, of course, now I can drill down into these clusters to get more insights here. So let's go into the dev test cluster here. And this will now give me a quick overview of the nodes, the CPU and memory utilization, the number of nodes, the node count, and also the number of pods running, and also in various states here. So you can see now that it looks pretty good. I have currently around 28 or something pods running in these clusters. I can actually also turn on the live interval, which now we switch to a live view. So it will just show me information coming in. And of course, I can also select different time periods here. So this is a nice overview. And another thing you can do here and should do here is related to alerts. So you can create all types of alerts here. I will show you that in a minute as well. But in addition to this, you have a lot of predefined alerts, so recommended alerts, which is things that you typically want to be alerted on. And this feature just makes it super simple to just enable these types of alerts. So for example, if I have containers having CPU being greater than 95% over a certain period of time, I can enable this alert to be sent to the SRE, for example. Also, if I have the number of pods in failed state are greater than 0, so if I have pods failing, I can also set up this alert just by flipping this switch. So this is something that you really want to enable. And again, then you can build more customized, more advanced alerts if you want to. So now what I can do now is, so this is kind of an overview, but then I can drill down here into my cluster to get more specific information. So these are my nodes that are running, and you can actually, it's kind of small here, but you can actually see the trend here in terms of CPU usage for each of these resources. So this is the node. It's kind of underutilized here, so it's hard to see it here. But then when I drill down here, I see the controllers and all the way down to the containers here. And so I can drill down into a specific container. I can see the CPU usage. I can switch to the memory view, see how is the memory going over time. And this is really good information when you're troubleshooting something that has happened. You can kind of look back, see what has the trend been like. Have we seen increase in memory or increase in CPU and so on. And again, I don't have to go all the way from nodes down to the containers. I can go directly to these containers. And in addition, I can also filter this, because we have in a Kubernetes cluster, you always have a lot of system pods running, and you might only be interested in your application. So I can filter it on my namespace. So now I only see my containers here. So these are my 3 deployments. I have a front end, a back end, and a database running here. So clicking at one of these containers, I can get some information about this container, status, environment variables, and so on. And I can also actually get the live data view here, similar to what you saw in Azure Pipelines here, which is also great for troubleshooting a running instance. So actually, we could go to the application. So I'll go to the dev. Dev. And actually, I have every time I select a category here, there is something that should send a log here. So you can see now that I logged just the selected category, just as an example of. So you can see now that the logs are live streaming here, which is great for troubleshooting. I can also see the events related to the pod itself. So I can see things like the image was pulled, which version it was created, started, and scheduled to a specific node, and so on. So great information available here in this view. Now, then we can work with the two different data stores that I talked about. We have the metric store. So this is where all type of metrics are stored. So I can easily now do charts type like showing me the number of pods across different states. And I can add multiple metrics, and I can create charts here. And then I can pin these charts to a dashboard. I can build dashboards with the information that I want to have. And basically all the resources, all services in Azure have this metrics store available on the Start Hub. So you can easily create your own metrics, and you always have this type of standard metrics chart that I showed you, on this page. So if you go into the virtual machine, for example, you will see a similar charts based on the metrics for virtual machines. Then in addition, you have the log analytics. So this is where all the logs information are stored. And here we can run a lot of different queries using a language called Custo. So I can, for example, let's do a container CPU query. So this is a SQL-like query. So I'm selecting information from the performance table, and then I'm doing some filtering, and I'm doing some aggregating. So I can view the results here either as a table or as a chart. You can see this is a huge amount of data, but even so, it runs really, really fast. And once I've created these charts or these queries, I can pin it to dashboard, but I can also create an alert here. So this is how you can build more advanced alerts by using these queries, and then you can create an alert. For example, saying that if the number of results coming from this is greater than a specific threshold value over a specific period of time, then send an alert. A typical example here. So really, really powerful, and the query syntax take a little bit of time to get used to it, but once you know it, it's quite simple to write these queries. And again, everything running in Azure will send data here, so you can do queries across multiple resources. So you can combine information from other applications, for example, application insights, in the same query here. So really powerful things. All right. So last part, availability and scalability. I want to talk about as well. When you're talking about availability in Azure, you have the concept of regions. We have the West Europe, East US, and so on, the regions around the world. And inside each of these regions, you have something called availability zones. So each of these zones, they are physically distributed. So they're not really close to each other. And the reason for that is, of course, that they should not be, for example, if you have a major thing like an earthquake or a thunderstorm, should not be able to wipe all these availability zones out at the same time. So each availability zone, in addition, then have multiple physical data centers, which in turn have independent power, the water supply, and cooling, and so on. So this is to make it available to build highly available applications that are not susceptible for problems that can occur. I mean, data centers can go down, or they can be, target of a denial of service attacks, for example, which by a particular region or availability zone would actually have degraded performance. So when you're deploying something into Azure and you want to make use of availability zones, so then you want to make sure that you're distributing it across multiple availability zones. So for example, if you're doing virtual machines or virtual machine scale sets, you want to deploy the machines into multiple availability zones, and then you'll have a load balancer in front of it that will direct traffic to it. So with AKS, you can take advantage of it and specify that you want to have multiple availability zones. So in this case, if I'm deploying 3 nodes, and I say I want to have 3 different availability zones, AKS will automatically distribute these nodes in these 3 availability zones. So if I have 3 nodes, I will have 1 in each availability zone. And then if I create more nodes, of course, they will be distributed across these zones. Again, this is very easy to enable, just specifying here in our template how many availability zones I want to have, or which ones actually. And so when you do this, you can set this up, and so you can deploy this into multiple regions as well. So within a region, you have multiple availability zones, so you have a high availability there. But then, a whole region, doesn't really tend to go down. But, in addition to this, you might want to be able to actually have a performance cluster no matter where the user is. You might have users across the world, and you want to send them to the closest one. Or you might have some kind of networking issue that actually causes problem in one of the regions. So to do this, you actually set up multiple regions. You deploy the same cluster into multiple regions, and then you put something like the traffic manager in front of it. And the traffic manager can then direct the users to the clusters, either by geography, so it sends you to the closest one, or by performance, so it can detect which one has the best response time currently. So you will send it to the cluster that actually performs the best at the moment. When you do this, you also want to make sure that you are replicating your container registry. So if you're pushing images to the container registry in your primary region, then when you have a cluster running in a secondary region, it would be not optimal to have it pull images from the other region across the world. It can do that, of course, but it tends to increase the time it takes for it to, for example, deploy new versions. So instead, you can enable geo-replication on the container registry. So when you push a new image to the registry in the primary region, it will automatically replicate it to the secondary region. So that cluster can now pull from the registry that is close to it. So related to availability is, of course, scalability. And there are different types of scaling you can do with AKS. The first one is called, when you talk about horizontal scaling. So you want to scale up the number of instances running. And this is something that is, it's a built-in feature in Kubernetes that you can enable and configure. And it's called the horizontal pod autoscaling, HPA. So if you enable and configure this, now you can then scale up the number of pods depending on how you configure it to handle an increased load. Now the next part is scaling the cluster itself. So you can scale up or scale out the number of pods to a certain amount, but at some point in time you will run out of resources on your nodes. Then you can enable the cluster autoscaler, which will then add additional nodes to your cluster and then automatically schedule the new pods onto that node, and therefore balancing the load over these nodes. And the pod autoscaler, it works like this. You have a deployment in Kubernetes where you specify which pods and how many pods you want to run. You can create the HPA and configure it. So this is one way of configuring it by using the autoscale command. So here I'm saying that if my pods are running above 80% CPU, then it should kind of enable the autoscaling. And I'm specifying here that I want to have at least 3 pods running, and I want it to scale up to a maximum of 10 pods, so I don't run the risk of totally consuming all resources in my cluster. But I want to have the autoscaler to scale between 3 and 10 here, depending on the CPU load here. And all pods running in a Kubernetes cluster, they send data to the metrics server API. And this is what the pod autoscaler reads and bases the decisions to then either scale up or scale down your deployments based on the CPU. So, and if you want to, for example, scale on CPU percentage, you also need to make sure that you're actually defining in your deployment what your application actually requests. So here I'm saying I'm requesting at least 250 millicores of CPU, and also have a top limit there. And this is actually used by the autoscaler to in the algorithm that it uses to calculate whether to scale up or scale down and how much to scale up. It uses this information to do so. So cluster autoscaling is simple to enable. You can just enable it and specify the minimum number of nodes here. There are more things you can configure, but this is the basic of it. And it's hard to demo cluster autoscaling live because it's not, takes a few minutes to set everything up. So actually, I ran this yesterday, and just to show you what it actually would look like after the fact is on the top there you can see the number of pods running the cluster, and on the bottom left you see the count of nodes here. And if you see over here to when the pods start to rise here, this is when I added some load to the cluster. And you can also see here that the number of pending pods are increasing here. So this means that the autoscaler wants to create more pods, but there's not enough resources in the cluster to do so. So this is a trigger then for the cluster autoscaler to actually create a new node. And once that is up and running, you can see that now we can schedule the pods here, and we don't have any more pending pods here. And finally, when the load has gone down, after a while, the cluster autoscaler will then also remove the node and go back to the minimum here, which is 3 nodes. And there's a final type of scaling in AKS, which is kind of cool. We call it serverless scaling. And this uses the concept of a virtual node. And so in Azure, we can take advantage of a thing called Azure Container Instance, which is a very fast and simple way of running containers. So instead of creating new nodes, which takes a couple of minutes, we can instead use a virtual node, which under the hood then will, instead of creating a physical virtual machine, it will actually schedule my pod inside an Azure Container Instance instead. And this is actually based on something called a virtual kubelet. It's actually an open source project, and this is integrated into AKS. And the virtual kubelet, it registers itself as a node. So for Kubernetes, it looks like a normal node. But what happens when the Kubernetes schedules a pod onto that node, what happens under the hood is that the kubelet will now instead create Azure Container Instances. So this is really powerful in certain scenarios when you have some type of burst load. So let's say that you have a queue-based system where you have some workers that are pulling messages from a queue, and suddenly you get a lot of messages that you need to handle. Then instead of either having a huge cluster or scaling up new nodes, you can instead use these virtual nodes, which is much faster because it's much faster to start container instance compared to creating new virtual machines. And so you can scale up from 0 and process those messages, and then it can scale down to 0 again. And of course, this also means that you don't have to pay for nodes running unless you really need them. So if you are running AKS, take a look at these virtual nodes. And this is something that you can just enable and then use when you find the need to. So I'm going to finish up with some demos on this autoscaling and availability. And first up, let me just take a look at the availability part. So this is the cluster again, and again we have the node pools here. So it says I have 2 instances here in my node pool. So under the hood, as I talked about before, this is a virtual machine scale set, which you can drill into if you want to, like this. So each of my cluster has a scale set. And if I go into my node pool here, you can see here that the location is multiple zones. And looking at the instances, actually, I can't see this in this level, but if I go into the actual virtual machine, I can see that this one is running in zone 1 in West Europe. And if I go into the other one, you can see this running in zone 2 in West Europe. So again, AKS has automatically distributed my node on top of multiple availability zones. And if I would add one more node here, it will actually be placed in the 3rd zone. So again, this is what we can do to make it highly available. And then to support the multi-region functionality that I talked about before. You can set this up using Traffic Manager. So when you're using a Traffic Manager, this is the endpoint that your users will browse to, and then it will redirect the traffic based on how you configure it. So in this case, I configured with the geographic routing method, meaning that it will send traffic to the closest one. So this is the URL. So if I go to this URL, I will be automatically routed to the closest one. And this can be seen here as well if I do a ping. Like this, you can see that it results to the EU cluster. But if I would be in the US or closer to the US, it will automatically direct me to that cluster. But I could also use then the performance routing instead to actually make sure that I always come to the cluster that is most performant in the current time span. So last up, let's demo the autoscaling part. And let's take a look inside my cluster here. If I do a get the deployment here. Oh, sorry. Do a kubectl get deployment in my namespace. So again, you can see that I have 3 deployments: the front end, the back end, and the database. And I'm running only one instance here at this point of every pod here, so it's not really, it's not really suitable now for a high load. So I'm going to enable the autoscaling. So I'm doing kubectl autoscale. I want to scale my front end, my web app. Of course, I could also autoscale the back end if I want to. And here I'm specifying that the CPU percentage should be just 10%. This is not really realistic, but for the demo purpose, it makes it easier to actually show you this. And I'm specifying that the minimum should be 3 and the maximum should be 10 here. So let's do this, and then I want to add some load to it. So I'm using this tool called Bombardier to just give it a lot of HTTP requests coming from my machine here. And actually, we can go back to see the insights view here. So if we're lucky, we can also see this scaling here as it comes in here. So if we switch to last 30 minutes and enable the live view here, we should be able to see the pod going up here in a few seconds. So basically now the pod autoscaler will look at the CPU load of my pods, and when it sees that the average CPU is about 10%, it will increase the number of replicas here. I can also monitor this using watching the status. So you can see now that it's actually currently it's 60%, so it's already actually scaled up to 6 instances here, which then you should be able to see this here coming in, that it actually increased the number of pods here. It might be hard to see on this scale, unfortunately. But you can see now that it's scaled up to 6 replicas, and if the load continues, it will go all the way up to 10 instances based on the CPU load here. So you can see now that the average is 31 because we kind of scale up a bit. So, but as long as it's above 10%, it should continue to scale even more. So yeah, so now it's actually scaled up to 10 instances. So if I do get the deployment kubebox, we can again see that we're actually having 10 instances here of my front end. This is completely done now by the horizontal pod autoscaler. And yeah, now we can see also here that the pod count is going up here. So this is how you can handle increased demand. And again, the autoscaler will then run, and if you configure it to, eventually you will run out of resources in the node, and that at that point the cluster autoscaler will kick in, and it will increase the number of nodes here as well. but I just showed you that on the slide as well because we can't really wait for that now. All right, I think I'm actually out of time, but that is what I wanted to show you. So talked about the infrastructure as code and deployment to make sure you have a safe, repeatable way of provisioning both the cluster and your application. How you can use Azure Monitoring to get insights into the cluster and application, creating alerts, creating charts, and so on. And how you can think and work with the availability zones and regions, and also the scalability functions in both in Kubernetes itself, but also in AKS to make sure that your application and cluster is available at all times to your end users. So with that, I want to say thank you. I hope you picked up some good knowledge. And please, if you have any questions, just ask them in the Slack channel. So I'll hang around there for a while after the session, and I'll answer them as good as I can. And hope you have a continually great conference, and hope to see you soon somewhere on the internet or physically. Thank you.